Hello, science enthusiasts, and welcome back to our channel. Today, we're taking a deep dive into one of the most incredible scientific facilities on the planet, CERN. You might have heard of it, but do you know what really goes on there? From discovering the building blocks of our universe to inventing something you're using right now, CERN is packed with mind-blowing stories. So, buckle up as we explore 10 amazing facts about this powerhouse of physics. Let's start with the basics. What exactly is CERN? The name stands for Conseil Européen pour la Recherche Nucléaire, or the European Organization for Nuclear Research. Founded back in 1954, its primary mission is to unravel the deepest mysteries of fundamental physics. It's located near Geneva, cleverly straddling the border between Switzerland and France. Think of it as a giant international laboratory where thousands of scientists from all over the globe come together to figure out what the universe is made of and how it all works at the tiniest, most fundamental level. It's a place built on collaboration, curiosity, and the quest for knowledge. Now, let's talk about the star of the show, the Large Hadron Collider, or LHC. This isn't just any machine. It's the largest and most powerful particle accelerator in the world. Imagine a massive 27-kilometer circular tunnel buried deep underground. Inside this ring, beams of protons are accelerated in opposite directions to nearly the speed of light. Then, at specific points, these beams are guided to smash into each other. Why? Because by recreating the high-energy conditions that existed just moments after the Big Bang, scientists can see the fundamental particles that make up everything around us pop into existence. It's like a time machine and a microscope rolled into one incredible piece of engineering. One of CERN's most famous achievements, made possible by the LHC, was the discovery of the Higgs boson in 2012. This was a monumental moment in physics. The Higgs boson was a particle predicted way back in the 1960s, but for decades, it remained a missing piece of the puzzle known as the Standard Model of Particle Physics. It's often called the God particle, but its real job is arguably even more profound. The Higgs field, which is associated with the boson, is thought to give mass to other fundamental particles. Without it, particles would just zip around at the speed of light, and the universe as we know it, with stars, planets, and people, couldn't exist. The discovery, made by the ATLAS and CMS experiments at the LHC, was a stunning confirmation of a theory that had stood for half a century. But CERN's legacy of discovery started long before the LHC. Back in 1983, using an earlier accelerator called the superproton synchrotron, scientists at CERN made another groundbreaking discovery: the W and Z bosons. These particles are the carriers of the weak nuclear force, one of the four fundamental forces of nature. This force is responsible for certain types of radioactive decay and nuclear reactions that power the sun. By colliding protons and their antimatter counterparts, antiprotons, the UA1 and UA2 experiments were able to detect these incredibly heavy and short-lived particles for the first time. This discovery provided concrete proof for the electroweak theory, which successfully unified the electromagnetic force and the weak force into a single framework. It was a giant leap towards a unified understanding of nature's forces, and the hits just keep on coming. Even before that, in 1973, an experiment at CERN called Gargamelle made history. Gargamelle was a giant bubble chamber, and inside it, physicists observed something that had never been seen before: neutral currents. They saw neutrinos, tiny, ghost-like particles, interacting with other matter without changing their identity. This might sound technical, but it was a crucial piece of evidence that supported the electroweak theory we just talked about. It showed that the weak force could act in a way similar to the electromagnetic force, further cementing the idea that these two seemingly different forces were just two sides of the same coin. The Gargamelle discovery was a key stepping stone that led to the later detection of the W and Z bosons. Now for a fact that has changed all of our lives, perhaps more than any other. Did you know that the World Wide Web was invented at CERN? That's right. In 1989, a British scientist named Tim Berners-Lee was working at CERN. He was frustrated by how difficult it was for scientists scattered across the globe to share information and data. So he came up with a solution, a system of linked information that could be accessed from anywhere. He created the very first web browser, web server, and the fundamental protocols that still power the internet today: HTTP, HTML, and URLs. His invention was initially designed for scientists, but CERN made the technology publicly available for free. It's one of the greatest examples of how pure, fundamental research can lead to innovations that revolutionize the entire world. CERN also delves into one of the most mysterious substances in the universe: antimatter. For every particle of matter, there's supposed to be an antiparticle with the same mass but opposite charge. When they meet, they annihilate each other in a flash of energy. But the big question is, why is our universe made almost entirely of matter? To investigate, CERN has a unique facility called the Antiproton Decelerator, or AD, along with its upgrade, ELENA. These machines don't accelerate particles, they do the opposite. They capture and slow down antimatter so that scientists can trap it and study its properties with incredible precision. They are testing if antimatter falls down due to gravity just like matter does, and checking for tiny differences that could explain the cosmic imbalance. It's fundamental physics at its most mind-bending. Smashing particles together creates an unbelievable amount of information. The collisions in the LHC happen billions of times per second, and the detectors capture a snapshot of each one. This generates more data than you can possibly imagine. We're talking petabytes upon petabytes every year. To handle this digital deluge, CERN developed the worldwide LHC computing grid. It's a massive global network of computing centers, linking hundreds of thousands of processors across dozens of countries. This distributed computing system allows scientists anywhere in the world to store, access, and analyze the data from the LHC experiments. It's a pioneering model for large-scale data science and collaborative research, pushing the boundaries of what's possible in big data. So, what's next for CERN? Well, they're always thinking bigger. While the LHC is still making discoveries, scientists are already planning for its successor. The current frontrunner is the Future Circular Collider, or FCC. This proposed machine would be a behemoth, with a ring about 91 kilometers in circumference, more than 3 times the size of the LHC. An accelerator that powerful could allow physicists to study the Higgs boson in unprecedented detail and search for new particles and phenomena that are beyond the reach of the current machine. It's a hugely ambitious project that's still in the planning and discussion stages, but it shows CERN's commitment to pushing the frontiers of knowledge for decades to come. Finally, while we often talk about protons, CERN's research is much more diverse. The LHC doesn't just collide protons. For about 1 month each year, it smashes together heavy lead ions. The goal of this is to recreate a state of matter called the Quark-gluon plasma. This is an ultra-hot, ultra-dense soup of fundamental particles that is believed to have existed for a few millionths of a second after the Big Bang, before protons and neutrons ever formed. The ALICE experiment is specially designed to study these heavy ion collisions and learn about the properties of this primordial state of the universe. It asks another way CERN is looking back to the dawn of time to understand the world we live in today. And there you have it, 10 incredible facts about CERN, a place where humanity's boldest questions about the universe are being explored every single day. From the smallest particles to the vastness of the web, its impact is truly immense. What did you find most fascinating? Let me know in the comments below. If you enjoyed this journey into the world of particle physics, please give this video a thumbs up and don't forget to subscribe and hit the notification bell so you won't miss our next adventure. Thanks for watching and stay curious.